Hey everyone! Today I'm going to be going over the creation of texture files for the source engine using the MareTF program made by craftablescience. So, what are VTFs? VTFs are a format used by Valve for the source engine. They basically are used to store images that the game can then read through the VMT files, which tell it what to do with the VTF files. VTFs are the actual information of the texture, and the VMTs are like how the engine actually uses that texture for the material. For creating textures for Portal 2, MareTF has a GUI that was added recently that allows you to easily create textures without having to use a command line. For Portal 2, you will want to use version 7.5. That's the latest version that you have access to in the Portal 2 source engine branch. 7.5 isn't that much different to 7.6, but you still will want to use it just to have its features. VTFs have a lot of different formats. For most textures, you will want to use DXT1. It's a compressed format, which means it'll have smaller file sizes, but it doesn't store alpha channels, which means it's optimized for non-transparent textures, which are going to be the majority of textures that you use. If you do have a transparent texture though, there's DXT5, which is basically DXT1 with all that compression, but it also has support for transparency, which allows you to make stuff like overlays or glass or stuff like that, or like storing like a Phong texture in the base texture. You would want to use DXT5. The other main formats that you might want to use, BDRA 8888. It's useful for gradient textures because it doesn't have any compression. So it's going to be the max file size that you can do, but it's going to also have the max quality that you can do. There's A8. A8 is basically just a white texture. It does not store anything but white inside the VTF, but it also stores an alpha channel. So you can use it for, like, let's say a white overlay that has like if you're doing a like alphabet signage, you could use A8 to have transparency for that overlay while also only like needing that white in the A8. And then in the VMT, you can do stuff like set the $color variable to like tint it per VMT. So it's pretty useful for like overlay stuff and also detail textures. There's also I8, which is, it basically just stores a grayscale texture. If you have a black and white texture, you'll want to use I8. There's also the RGBA 16 and 32, which are going to be used for HDR textures. Most of the time you won't be using HDR textures because those are mainly like skybox, cube map, light maps, etc. For this texture that I'm making, I'll want to use DXT1. MareTF also lets you set the compression quality that the DXT uses. Most of the time you don't really need to touch this unless you're like a psychopath who wants extra quality. Because the compression quality, if you like it, depending on what you set it, it can set your VTF compile times to be like exponentially longer. I've had, like, when I've experimented with this stuff, I've had VTFs that take like 30 minutes to compile when I messed with the compression quality. You can also tell it to resize the width and height. I personally don't really usually use this, but it's useful if you like want to change like a 2K texture to be 512 or whatever. You can also set the bitmap algorithm. Usually you don't need to touch this, but if like you have specific like details that fade away when you move far away from the texture, then you can try compiling it with the different algorithms here. Nice is the filter that Valve uses to maintain like the crispiness that their textures have. There's also Caser, which is very similar to Nice, except it's supposedly better. And then there's these other ones, which all do different things. And they're all pretty self-explanatory. Box is like box filter, bilinear is bilinear, point sample, etc. You can also use MareTF to convert HDRI skybox textures. You can use it to set equirectangular HDRI textures into cube map textures, which is useful for like if you're importing a skybox texture from another game into the source engine. However, this isn't a skybox texture. If it was, I would be using the HDR formats. You can also set the gamma correction for if your game has like weird gamma information on the screen. And you can invert the green channel for importing like OpenGL normal maps. And you can also affect the normal map scale as well. Since this is in a normal map, I'm not going to be touching these. And then texture flags. For the most part, you don't need to touch these. They are usually set manually depending on the suffix that you add to the texture. So stuff like underscore color, underscore SS bump, underscore normal will all be automatically added to the flags. And these flags are used internally by the engine for like, usually for debug stuff, but also just like to tell the engine specifically how to render the texture. Clamp S and clamp T are going to be like the flags that you will likely be changing, like if you ever do need to set the flags. And clamp S and T, they basically tell the texture to not tile. So like after like you get to the edge of the texture, it just goes into black or null noise. There's also point sample, which changes it to a point sample texture if you want to use art stylization in your graphics. There's sRGB, which is usually set by just adding an underscore color suffix, but it tells the engine that this is using the more modern sRGB texture stuff. You can also set like metadata, LOD stuff, thumbnail, etc. And voila, we have our texture here. It's 1K, one frame, has bitmaps, computed the reflectivity, and we can see that it has the bitmapping, which is pretty awesome. For strata stuff, it's a lot of what I've said will apply. However, instead of 7.5, you'll want to use 7.6. 7.6 is a special format that Strata uses for their own textures that has a lot of more modern features from modern technology. And Strata allows you to have BC7, BC6H, and better ATI 1N. BC7 is basically DXT5, but it has higher quality when it's compressed. So you basically have the same amount of file size, but higher quality when using BC7 in comparison to DXT5. BC7 has an alpha channel, so the file size of BC7 will be larger than DXT1. So you still want to use DXT1 if you don't have an alpha channel. But if you do have an alpha channel, you can use BC7. BC6H is basically BC7, but for HDR textures. So if you have like a skybox or a cube map or whatever, then you can use BC6H to have that HDR colored data. And then ATI1N is very similar to I8, except it uses that BC compression that BC7 and 6H have. And so it will have a smaller file size than I8 because it'll have that compression. However, as of currently, Strata reads ATI1N from the red channel only because that is inherently how it's stored. And so if you use it as a base texture, it will be red in game. If you need like a grayscale black and white texture, you would use I8 for the base texture. But if you're using like a tint mask or something, then you'll want to use ATI1N. Since this doesn't have any alpha, I'll just keep going with DXT1. It's pretty much the same from here, but 7.6 also allows you to have CPU compression. This basically allows you to have smaller file sizes for the texture, sometimes like up to half the file size, which is pretty big, so to speak. Z standard is the best for this. There's also deflate, but deflate has very similar sizes to Z standard. However, deflate also has very high load times. It'll take a lot longer to load the textures in game, which means longer loading times, loading screens and stuff if you use deflate. Versus C standard is more optimized for that loading time. And then level, usually I like to leave it at 100% because like the CPU compression doesn't usually affect how it looks in game. The GPU compression, the format, does affect it very slightly. And the flags are basically the same. Yeah, we have a 7.6 Z standard Strata format VTF. MareTF also lets you input stuff like GIFs and WebP and all sorts of fun formats, so feel free to play around with it. That is texture creation using MareTF.